Okay, it is 8 in the morning Pacific time. Why don't we get started? Good morning, good afternoon, good evening to the global tinyML community and our guests. Welcome to the May edition of the tinyML Trailblazers series. So this is the place where you're going to meet people who are making significant impact in the tinyML world, who are effectively tinyML masterminds and trailblazers and mavericks, people who really make the tinyML revolution happen. And we are very fortunate to have a very special guest today. Is Dr. Thierry Moreau. I remember when I first met Thierry, it was maybe like 4 or 5 years ago. Back then, he was a student in the University of Washington, and he was given a very interesting presentation on the work he was doing back in his graduate school days. That was a presentation in Qualcomm, and now Thierry is a co-founder and VP of Technology Partnership at OctoML. It's a very successful company developing solutions, TVM solutions, basically to the whole ecosystem. So in this just 2 years, the company has grown from again a graduate student project to a company of the size of over 140 employees. And those of you who follow the news in tinyML, they successfully raised quite a bit of VC funding in the past year or two, over 100 million, and that basically a great testimony of what the venture world, what the community world wants this company to succeed in this space. And Thierry is going to reveal his secret and the company's secret recipes today, and we're really looking forward to this discussion. And the host of today's event is going to be our famous Chris Rowen. Chris is very well known also to this community, and we will introduce Chris and Thierry in a moment. But before we do this, let me acknowledge tinyML strategic partners. So this list keeps growing every time we have this event. We have about 35 strategic partners now. It's Analog Devices, AON Devices, ARM, DeepLight, Edge Impulse, EMSA, PhotoHub, Greenwave Technologies, Gravity Inc., HRTG, Imagimob, ITMIS, ClickerTech, Latent AI, NXP, Prophecy, Kixo, Qualcomm, Reality AI, Rixon, Renaissance, SAP, Seed Studio, SenseML, Sony Semiconductor Solution Corporation, ST Microelectronics, Stream Analyze, Synaptics, SynSense, and Sentient. And I'm also very pleased to announce that OctoML is also joining tinyML strategic partners, because OctoML is really an important player in the tinyML ecosystem with the technology they're developing. And many companies already using this technology, and I'm sure Thierry is going to give us a snapshot of this. Many of you know we had a very successful tinyML summit. It was a really high energy, high passion event of the whole global community. And kind of the point here is that now you can get presentations on the website, and most of the videos from the event are on the tinyML YouTube channel. You can go there and check them out if you miss some of these presentations. Our next tinyML Trailblazer event, the June edition, will take place in about a month on June 7th. And the guest will be Mona El-Khatib. She is also co-founder and CEO and CTO of AON Devices, also very, very interesting company providing audio solutions for NIP for the industry. And you can register now. So the communities keep growing. So I think we are approaching 10,000 members on Meetups in 45 groups. And the LinkedIn community is growing. It's a lot of excitement in tinyML. So if you're interested, there are QR codes on the left. You can click and join these communities, and then you will be up to speed on all the announcements and news and events happening pretty much every week, almost every day there. And this presentation will be recorded and it will be available on tinyML YouTube channel tomorrow. So you can also subscribe to this channel for updates and notification. Also, it has close to 7,000 subscribers now, over 400 videos. So it's a lot of excitement and a lot of information there. Let me introduce our amazing host. It's Dr. Chris Rowen. Chris is a very well known in the industry and in the Bay Area for many good reasons. As an entrepreneur, as a technologist, as a successful lead of and a founder of several companies. Currently he is at Cisco, where he leads AI group there. Before Cisco, he co-founded Bubble Labs, and that's how Bubble Labs was acquired by Cisco in 2020. And he has a lot of significant industry recognition, like he was a founder of Tensilica and the CEO of the company. And he was working on risk architectures and MIPS architectures since quite some time ago, after his degree, physics degree in Harvard and a PhD from Stanford. And Chris has many recognition, including IEEE fellowship and so on. So really glad to have Chris as our host here. And Chris, the stage is yours.
Thank you very much. It's a pleasure to be here, and it's a particular pleasure to be talking with Thierry Moreau, who is the co-founder of OctoML, which is one of the very successful companies in this space of building platforms to proliferate the practical use of machine learning across a very wide number of applications and hardware platforms. He got his PhD from University of Washington, where he worked on Apache TVM, and he's really at the heart of building this new enterprise. And so he's a perfect guest for this series, where we focus not just on, well, what are the interesting new products or what are the interesting new ideas, but what's happening at this magical overlap, at this collision between an idea and a marketplace and actual users. How do you get some good idea into widespread use in a way that really changes what the broader community of developers and engineers and product builders can accomplish? So Thierry, welcome. And maybe the place we should start is kind of the origin story. How did OctoML come about? What was the premise? What were you thinking?
Yeah, well, thank you so much, Evgeny and Chris, for the great introduction. It's a real pleasure and a real honor to be here to talk about the origin story of OctoML, what led us to essentially start this company, and what is behind our technological secret sauce, right? TVM, this project that started in academia. So in order to talk about the origin story, I think we have to rewind the clock all the way back to 2017, so about 5 years ago. And it's worth noting that at the time, the groundbreaking innovation of work like AlexNet was only 5 years old, right? And this work really brought a lot of attention around deep learning and how revolutionary it could become, how transformative it could become. And at the time at the University of Washington, I was working with a group of researchers around this Apache TVM project. And so if we think back about the context at the time, we started seeing the first very popular deep learning frameworks like TensorFlow and PyTorch being released in open source, right, in 2015, 2016. And these tools really allowed, I would say, machine learning practitioners to focus on the problem, to focus on the data, to focus on the design of architectures, rather than having to build all the software required to to essentially get kickstarted on your endeavor. And so by raising this abstraction to focusing on these problems, we really unlocked a lot of productivity. And at the time, we we're looking at the next frontier for innovation in the machine learning landscape. And that frontier was in compilation frameworks. And we wanted to solve this problem of machine learning deployments. What happens once you've managed to train your model to achieve, the function that you wanted to do, and how do you take this model to run efficiently on a multitude of hardware platforms, whether we're talking about the edge or the cloud or even IoT devices. I think it was an interesting time to get started on this problem because at the same time, as we started seeing this proliferation of frameworks, software tools, runtimes, libraries, we also saw a proliferation of new hardware IPs, accelerators that could really bring a lot of capabilities onto the edge and onto the data center. And so this project, Apache TVM, was built out of this desire to provide this infrastructure that would let you take models, regardless of what you trained it in, regardless of what format you chose to represent it in, and compile it on essentially any hardware that provided some compute capabilities to essentially make any device, any system intelligent. So we started working on this project at the University of Washington, and the project gained a lot of traction. So the originator behind this project, Tianqi Chen, who's our chief technologist and one of the co-founders of OctoML, had already started several open source projects, including XGBoost and MXNet, which is this deep learning framework that has been heavily backed by Amazon and AWS. And we really believed in this idea of open source collaboration to make an impact, to see the technology transfer from academia into industry. And one thing we found in the early years of the development of this project was that we were gaining adoption, we were gaining contributions from not just academics, but also engineers working in companies like AWS, Microsoft, and Facebook, using this technology to optimize model, get them deployed into production environments, and really make a dent in terms of taking these models that are essentially living in someone's IPython notebook that they're serving on their development machine and deploying it at scale in production. And so as we saw this traction, as we saw this participation of not just these giants, right, these hyperscalers, but also hardware companies like Xilinx, Qualcomm, ARM, who saw the potential of building their software tooling around this open infrastructure, we saw an opportunity to build a company. We told ourselves the technology has a lot of promise. We're seeing traction. We're seeing companies that have, the resources, the engineering know-how to solve these problems that are adopting this technology. What can we do to build a company around this innovative project called Apache TVM? And that's when in 2019, several of us from the University of Washington, including Luis Ceze, who at the time was a professor, he had experience working on several startups. He was well connected with the startup world and VCs. And essentially he saw an opportunity we can pass on and really got a bunch of us, grad students. There's a team of 5 co-founders, so 3 researchers from the University of Washington, Luis as a CEO, and we also worked with Jason Knight, who was at the time head of software product at Intel AI. And so he had this product mindset. He was really obsessed with this idea of identifying the product market fit for this kind of technology, having worked at Intel, having built software solutions for a wide portfolio of hardware co-processors and accelerator cards. And so ultimately we started this OctoML company in 2019. And in that summer, we had 5 people, the 5 co-founders, and today we're at over 130 employees. So it's been a really wonderful adventure. And our goal was to try to make a dent, to make it easier to get models into production on the edge on the cloud on IoT devices and make it
Right.
as accessible as possible by building this platform.
Often when people are designing, what is their strategy? What is their product? It isn't just that they look at the market the same way as other people and try to come up with a different solution for the same problem. Often success relies on looking at the market and seeing a quite different problem and therefore solving it. So how is your view of what the problem is different from other companies in the space? Because there are, a number of companies that are building the various kinds of platforms to accelerate the product development into this embedded, heterogeneous machine learning environment. So what's the problem definition which you think is most starkly different from the way that other people are defining the problem?
Yeah, that's a great question. And when we started the company, we wanted to see, okay, what can we achieve with a technology like Apache TVM? Because in a lot of cases, this technology gave us an advantage in terms of reaching levels of performance, enabling the deployment on platforms that were not supported prior to enabling these capabilities in TVM. So, we looked at essentially the must-haves and nice-to-haves, right, for deploying ML in a production environment, whether you're talking about the cloud or the edge. And I think depending on who you talk to, you get different stories, different information. Sometimes performance is absolutely a must-have. Sometimes it's a matter of, shrinking your model to fit within memory constraints. Sometimes all of these boxes are already checked, but they just require the automation and the tooling that makes it convenient to go from something that has been freshly trained to something that can be deployed at scale in production, or something that can be deployed on the edge, right? And so depending on those needs, we saw that we were sitting on top of technology that provided clear differentiation because of the performance advantages that it gave you, but also because of its ability to target hardware platforms that were not targetable prior to TVM being introduced. And so I think really working backwards from being able to have these models into deployment, we try to look at how we could automate a lot of the tooling so we could ultimately reach ultimately build this platform that let our customers successfully deploy models into production with the convenience and automation of DevOps. And I think that was something that we realized along the way for a lot of our customer base, a lot of the potential customers that we were talking to, that ultimately they cared about the ease of use, the convenience, without necessarily knowing what lied under the hood. And so our secret sauce here, the Apache TVM, would help us essentially capture the needs of end users, solve the problems that they faced in deploying those models, while building on top of other tools available at our disposal, other runtimes, other libraries, other frameworks that could essentially make it easy for our average customer base to get those models deployed.
Got it. Now, one of the big strategic questions that every startup faces, and is sometimes one of the most controversial, is how horizontal or vertical is the strategy? Horizontal implies I'm going to serve a wide range of customers across a wide range of applications, and I'm just supporting one layer of the problem. And vertical says, I know a lot about this end market application, and I'm really involved in building up the whole stack from something close to the hardware to something very close to the end application. How has OctoML wrestled with this problem over time of how horizontal to be versus how much vertical domain expertise to bring to the party?
That's also another excellent question, and I think when we look at the end-to-end vertical MLOps flow, starting from gathering the data, sanitizing it, doing model exploration and training, and then tackling the deployment problem, we chose to focus on that later half of the MLOps development cycle. We found that our strengths were really in the inference portion of the cycle, that our strength was really in taking the train model post all of the training, model architecture search, etc., but solving this problem that we found a lot of our users were facing, a lot of the pains that they were experiencing in actually figuring out, well, now that you have a model, how do you get it deployed in production? And so in some ways we are focusing on a horizontal slice, but I would say that this slice is actually exposing a lot of interesting challenges. There's a lot to work on, specifically on this model deployment problem. And we found that there were a lot of pains that our users experienced when it came to, for instance, having independence to choose between models that were trained in different frameworks, right? You might have really great tooling at your disposal to take a model and running it on an edge device. But let's say if you had to retrain it in a different framework, all of a sudden the tooling wouldn't exist anymore. And we also found that it was difficult for users to, for instance, take machine learning that they were deploying on edge devices built around a certain vendor's set of SoCs. Let's say they were using NVIDIA SoCs and they wanted to transition to using Qualcomm SoCs. That transition was very difficult. And we wanted to abstract away a lot of the pains from having to cater your deployment for a specific vendor solution. So really the idea was to try to abstract away the hardware that you were running your models on. And focusing on this problem is a big challenge in a whole. But if we could get our the target audience here, which are machine learning developers that don't want to be spending their creative cycles on how they're going to get their models running on edge devices, what kind of tools, what kind of libraries, what kind of expertise is required to run these models on edge devices. If we could get them to spend their creative cycles thinking about gathering the right data sets, framing the problem in a way that will that will address the core problems that they're trying to solve, and ideally just press on a button and say, okay, now I have this platform and I want to deploy it there. How can I make this part of the MLOps cycle as seamless as possible? And really the goal here is to accelerate the ML innovation cycle, so we don't have to worry about all the steps needed to essentially get your model running on the edge.
Yeah, right. So you're not solving the whole process problem from beginning to end, but you are effectively focusing on a piece of it that is fairly similar across different application domains. It's not like, oh, well, this is good for audio problems, but don't bother with video problems, or this is good if you're targeting tinyML, but if you're expecting to burn more than a watt, this isn't relevant at all. So it's not very vertical. In fact, it's really adopting one of the other successful templates for a startup. I mean, one template is sort of go vertical first. Another template is start from open source and build the professional version of a successful open source model. And of course, that comes in lots of flavors from, well, we're really productizing our university research, and we represent most of that community of users. And the other extreme is sort of, Linux and Red Hat. Linux was widely proliferated before Red Hat came along, and they sort of said, well, we're going to be a professional version of this thing that lots of people are using. Where in that spectrum does OctoML live? So how much momentum is there for Apache TVM outside of OctoML? And what are the implications in how you win business or how your customers see you in that ecosystem of Apache TVM?
Yeah, that is such a great question. And really from the start, when we chose to start a company around Apache TVM, we faced this question, right? I think there's a lot of analogies out there, like the ones you mentioned, are including Databricks and Spark, right? Of when you're building a company around an open source project, do you create a more industrial strength version of it? Do you essentially fork the development, make it more robust, and start selling it, licensing it to end users? Or do you continue to pour energy and resources into making the open source version more approachable, right? And so from the start, we actually chose to go with the latter, which was, let's not fork this project. Let's not create an industrial strength version of Apache TVM, but let's instead focus on building more critical mass around this open source project. And mostly, I think that this was a necessary condition to making TVM, which was, the core of a technology, relevant in a landscape where a lot of the frameworks, a lot of the ML AI software tooling is open sourced nowadays. And it was important for us to build this open source project around a governance model, the Apache governance model, that empowered other players, whether you're a software company or hardware company, to contribute to this project and really build momentum around this project. Because we found that there's essentially two ways to build critical mass around an open source framework like TVM. One is to build more interoperability and more connection points with other frameworks and other tools, right? Making it easier to take models from TensorFlow or PyTorch or TF-Lite and Keras and MXNet and import it into this compilation framework and optimization framework, but also bringing on more hardware vendors, partnering with the Qualcomms of the world and the NVIDIAs of the world and AMDs of the world to provide these compilation capabilities. And the more you bring hardware vendors under this umbrella, the more it is compelling to create those connection points with other software frameworks, other training frameworks, because for the people behind the TensorFlows and PyTorches of the world, it is compelling to target devices that they today cannot target. And flipping it the other way, the more interoperability points you provide with runtimes, with frameworks, etc., the more compelling it is to bring more hardware vendors under the belt. And so there was this incentive to get this flywheel going and really keep it as open as possible, improving the open source solution. And so as a company, the next challenge is, well, if you're having an open source technology, anyone can just use it, right? Any company can start an engineering team and can deploy TVM internally to solve this ML deployment, this inference deployment challenge. So that's why we chose to focus on building SaaS, building automation, building convenience, and focusing on that second half of the full MLOps cycle, which was the deployment. So what kind of convenience can you provide? What kind of automation can you provide, which a lot of us are familiar with in the DevOps world, right? And the DevOps world is a really big industry. And so what could we do to make it as easy as possible for folks to leverage this technology without having to write much code, without having to set up much infrastructure internally.
Right.
TVM, for instance, relies on hardware optimization in the loop. So you need to build, a fleet of devices for optimizing these models on smartphones or edge devices, et cetera. And so, truly the idea was to eliminate as much as the pain as possible and provide as much convenience to our end users.
Right. Let me turn to another kind of company building question. When you're doing a startup, the question is rarely, did you run into trouble? You always run into trouble. And it's just a question of which trouble did you run into? So tell me a little bit about not just a challenge, but a setback, something that in some sense went wrong and you had to course correct and do something different along the way. What is a real difficulty you had with the technology, with the funding, with the strategic direction, with the organization, whatever it is? Give me a sense of some really serious speed bump that you hit.
Yeah, I was expecting this question, and certainly, we wouldn't be where we are today without some real scars, and there's plenty of stories to share. But I think I'll try to focus on one which had to do with really adjusting our trajectory due to the realization that most end users of our platform, most end users who were concerned about getting models deployed, didn't really care about the underlying technology. For them to know whether you use TVM or not is a secondary matter. And I think that's a hard realization to have as academics, because in academia, you're really conditioned around, building the hammer and sort of finding the nail. And when you're building a company and trying to iterate on a product and finding product market fit, as you open up the aperture of potential customers you talk to, there is a whole spectrum of user sophistication. And I think coming from an academic background, you realize that everyone that you initially talk to in the academic world and around this community of developers in this open source project have a very high level of sophistication on machine learning. Those are the people with the PhDs. Those are the people who are compelled by tackling the hard problems. But as you start to look at what the average user really needs to make their deployment of ML models successful in production, you realize that you don't always have to tackle the hard problems head on. I mean, you do have to do that in a lot of cases, but if you want to capture, I would say, a broader business, there are a lot of users who essentially wouldn't care about what technology you're using under the hood, as long as it's fast, as long as it's efficient, as long as it meets your SLAs, and as long as it provides ergonomics and automation. And so just to tie it back to your original question, initially there was this strong bias towards catering to users and customers who were already very familiar with our core technology. There was a bit of a selection bias because at the beginning, we were very much seen as the TVM company. And we still are today. We're still very much invested in TVM. It's clear that this is a key differentiator, but we've shifted our story around being the ML deployment technology because we wanted to abstract away what underlying software tooling we're using, because we always wanted to give people the best deployment solution depending on their needs. And that solution may or may not include TVM. And so the pivoting that we had to do around this was trying to embrace the diversity in ways in which you could get your models into production, whether it involved our core technology or not, just to solve these end-to-end use cases successfully. And I think for a lot of us, it meant is essentially broadening our focus away from what I like to refer to as the performance battle, beating every single solution in their own turf, right? For instance, how can you do better than NVIDIA and NVIDIA GPUs or Intel and Intel CPUs? But instead, embrace a mix of solutions here that would involve other vendor-specific tools in essentially what is a patchwork of runtimes and code generators that would give you every step along the way a functional solution that you can package and provide to your end user. And I think this was an interesting realization that we had to make along the way.
Great. We have a few questions starting to come in from the audience, and I encourage the audience to post more questions. I've got one more company building question, which is, you've gone from 5 people in 2019 to 130 or 140 over the course of 3 years. That's pretty steep growth. Why did you grow that much? What do you need those people to do? And what have been the process and the cultural impact of growing so rapidly? Potentially in, I don't know, perhaps multiple locations? Is it all in one place? How have you coped with that, particularly, growing like that through the pandemic?
Yeah, definitely. On your last point, through the pandemic has added an extra layer of difficulty, and much of that growth was done remotely as well. So I think there's this question of when you're a startup, you have the option to raise funding quickly and scale your team rapidly, versus trying to stretch funding as far as possible and focusing on finding ways to build recurring revenue, right? And so in our case, we scaled fast because we identified that there were several needs that we need to fill. One was building our SaaS tooling, which requires a lot of highly qualified engineers that can build our platform, that can build and automate a lot of our infrastructure, to provide this to build the SaaS solution. But also we needed to hire a lot of highly skilled engineers to build our core technology around TVM, to extend this compiler framework to support more use cases, to extend the number of devices that we could support on the edge, but also build the sales and product teams that sustain this growth, right? That can help us iterate in our go-to-market motion. And truly, we saw that it was important for us to move fast and to build this product quickly, to iterate quickly. And that's why we chose to take on funding at the time to essentially scale the company to the size that it is. But it does, create some challenges, of course, because I think it's important for a company to preserve its culture as it grows. And when you grow really fast, I think preserving culture becomes a challenge. And also it falls on the co-founding team to make sure that we stay true to our cultural roots, right? And having to do this in a context where everyone's working remotely and we're in the middle of the pandemic has added an extra layer of difficulty. But I'm very happy with how our team has grown, and also quite surprisingly, we've as a company, I'm very proud to say that we've been able to retain a lot of our employees throughout this growth, which shows that they really believe in the product and the technology that we're enabling along the way. And that's been, I think, the most satisfying aspect of growing this company, ensuring that you're you're building this strong culture in that our employees feel very happy and compelled to be working with us every day.
Yeah, that's great. Let me turn to a couple of questions that have come in. Actually, Evgeny asked the question, what are the specific challenges for applying TVM for really tiny applications on microcontrollers, ultra low power, often battery powered, when you got this tiny silicon as the ultimate deployment target? What are the specific capabilities built for that? What are the specific problems that you solve or need to solve in order to make that really work?
Yeah, so that's a great question, and I want to connect that question to the OctoML's talk given by Andrew Roish, who's our technical lead behind the MicroTVM effort within OctoML, and he gave a talk at the tinyML summit on MicroTVM. And so essentially MicroTVM is the answer to what Evgeny asked. How do you adapt TVM to enable compilation, packaging, and deployment to devices that don't have fully fledged operating systems, right? You don't have files, there's no dynamic library, you might not have virtual memory or advanced programming languages. And how do you leverage the automation, the optimization capabilities that TVM provides in order to enable compilation and deployment and packaging on the tinyML, on the tiny edge? And so MicroTVM is this project that started actually around the time that we started OctoML, because we recognized that TVM as a technology could be adapted. There were a lot of benefits that people saw in using TVM, including a fairly lightweight and minimal runtime, the ability to ahead of time compile models into source code that was easy to inspect. And so you can imagine that if you're a car company or a robotics company and you want to inspect essentially the code and the libraries that are generated to run to implement a model, you have this ability to audit your code, and you have this ability to just take all that you need to make this machine learning deployment possible. There was no need for additional libraries or dependencies. Everything is self-contained because we don't use interpreters in TVM. Essentially, we're generating all the libraries that implement the model itself ahead of time. And so this MicroTVM project was grown out of the community. So it wasn't just an effort that OctoML built, because it was a community effort, which goes back to your question about the benefits of keeping of continuing to invest in an open source solution, because a lot of it was built by our partners, including ARM, who contributed to so much of MicroTVM, including the command line driver, its ability to do ahead of time memory planning, which allowed us to essentially tailor how much memory footprint a given model occupies when it is deployed on a tiny device. And so we've been growing the MicroTVM project. There is a community that is built around it. We've seen contributions from a lot of external companies, and we are essentially iterating on the solution. This year, we want to submit our first MicroTVM-based results to tinyML perf, which will allow us to essentially benchmark this solution against other solutions. We also have this great tutorial that shows how to get models deployed on Arduino platforms. And essentially, we're trying to cater to the vast community of hackers, of folks interested in running tinyML on the edge. And we're very excited by the early results that we've been able to obtain with this MicroTVM project. And so I'd love to make this announcement as an invitation for people to take a look at this project and find ways in which they can contribute, because we see a lot of promise in this direction.
That's great. That's actually a good setup for this question from Anton Lokmatov. Says, do you benchmark your product against competition, e.g. Deci and Neural Magic?
Yeah, so that's, hey, Anton, by the way, I know Anton quite well, so it's great to see your question here. And so, yeah, this question of benchmarking, I think, is really, really great because, I mentioned MLPerf as a way to essentially provide repeatable benchmarking results that can be audited by third parties that are reproducible and meet a certain level of quality, right? And we all know that this question of benchmarking is very challenging. This question of results reproducibility in the field
but
of
like they say,
ML and
lies,
AI.
damn lies, and benchmarking.
That's right. I think we've seen enough papers, and I'm sure many of us have tried to reproduce results. And this is definitely an area that OctoML is, has been investing into. For instance, last year we had built our first MLPerf submission around TVM in order to make MLPerf benchmarking more accessible. And we want to be able to do this on the edge as well in order to demonstrate the ease of use, the convenience of TVM to run ML on different edges. And so when we're comparing against other companies that provide similar value proposition, I think really the key here is to provide complementary value. Because one thing that's important to note about TVM is that it does not require retraining. And so when you look at the way we've built our SaaS product, we've built it around the assumption that a model has already been trained, has already been fine-tuned potentially, and has already been quantized. And now you just need to get that extra edge of efficiency running it on your target hardware. I think it's worth mentioning, I think, an anecdote that I like to share, which was in David Patterson's talk a couple of years ago when he was, advertising the success of the TPU effort within Google. And I think one thing that was fascinating was the fact that when they looked at MLPerf results over the span of 6 months, they saw results on the same workloads running on the same hardware having improved by up to 3x, which is absolutely mind-blowing, because imagine if LLVM or GCC gave you these performance improvements. And this is really what we wanted to provide, which was all of this, the bespoke optimization that does not affect the model architecture or the parameters of your network. And so when you compare against other solutions that require fine-tuning, revisiting model architectures, changing the parameters, you face other problems, like having to provide the right data sets to the service that will perform all these adjustments and optimizations. And we're trying to make this as easy and convenient as possible. So not having to provide data as part of the process, because there's a lot of hurdles that you have to overcome when you're being entrusted to handle another company's data set, right? And so from the perspective of comparing OctoML to other solutions, we were trying to make it as easy as possible for our end users to upload their models for all the bespoke optimization we're going to apply to them without having to necessarily share all the data sets required to retrain the models. And I think that's what makes our solution particularly powerful.
Mm-hmm. Great. Another question. Bob Allen asks, edge devices are far more diverse than cloud, and so the edge devices have tremendous value. How do you plan to extend value to the edge beyond what the open source project provides? So it's really the core question of what additional value at the edge can you provide beyond the open source environment, particularly around the edge?
Yeah, definitely. And I think this is where OctoML is essentially works as a force multiplier. Because as a company, on top of building our SaaS product, we've been working directly with the hardware vendors, with the silicon vendors to, together extend the capabilities of the TVM project. And so that means bringing more devices, more IP cores under this roof, under this umbrella. But in terms of providing value on top of what Apache TVM provides, really what we're trying to do is lower the need for your team to build all this infrastructure. Imagine if you had to set up fleets of devices so you could run TVM based auto tuning, so you could do performance evaluations and benchmarking. And what if instead you had a platform or a tool that gave you all of those insights? And so today, if you use the OctoML platform, you can take your model and see how fast your model runs on different devices and see how well it runs on, the NVIDIA solution or, a Raspberry Pi or, ultimately down the road, the Qualcomm solution, et cetera. And this has a tremendous value to end users who just want to quickly inform their decision on how to build systems that are most efficient. And, doing this well in the cloud, where you can select the instance that gives you the most bang for the buck, right? Cost normalized throughput based on the instance pricing, or doing this on the edge if you're a system designer and you're trying to figure out, okay, for the next generation of VR headsets that you're going to build, what SoC is best suited for your deployment needs, is something we aim to provide as easily and seamlessly as possible without having to essentially build all the test infrastructure in-house to draw these comparisons. And even today, you can see what the result of this looks like when you're comparing a lot of different instances in the cloud or edge solutions. And I think that's really great because it gives you the kind of information and the kind of intelligence that a project like MLPerf gives you, but in a way that you can drive the generation of results yourself on bespoke models rather than, standardized models that don't really represent the end use case for most ML practitioners.
Yeah, that's great. I have another question from Ben Koopman. You mentioned that OctoML's strengths focus on inference. Does that mean that OctoML's performance features, such as quantization, do not include in-training?
You mentioned that OctoML strengths focus on inference. Does this mean that OctoML performance features such as quantization do not include in-training model compression workflow like quantization-aware training? And more broadly speaking, if not, do you see OctoML focus expanding to training as well beyond inference?
Oh, thank you. Yeah, thank you for reiterating the question. So definitely, I think there's plenty of problems to solve on the inference side. Now, when we're talking about combining the power of, optimizations in TVM that we leverage in our SaaS platform, along with other techniques like model compressions using quantization in our training, that's really when you start to have a really powerful solution that explores optimization along different axes. Today, we essentially assume that you've already done the quantization or training because you are in possession of the data sets that you're using to do this fine-tuning or this quantization or training. And once that is done, it is handed off to our platform in order to apply an additional layer of optimizations. In the future, however, I think this is entirely something that we would be considering in the context of optimizations and deployments. So I think that there's just a lot of additional complexity to consider, which of course is something that has to be tackled down the road if you want to enable all of those fine-tuning or compression workflows. But as of today, the strength that we're capitalizing on is serving inference, packaging models for inference, and applying optimizations once the parameters and the model architecture have been well defined.
I think my network is back, at least for the moment. I've got one more question here, and then we should wrap up. Mark Donaldson asks, many companies are using IoT to boil the ocean by collecting all sensor data in the cloud and performing ML and data analysis there. How can the low-code or no-code tools like OctoML convince businesses that using IoT without edge intelligence on edge devices to leverage the value that edge ML provides, especially the environmental benefits? I take that to mean, how can you get people to move inference back to the edge, back to near the sensors, in order to be more efficient, more environmentally responsible in the overall structure of the solution?
Yeah, and I think I can connect this question back to this point of trying to abstract away what hardware platform you want to deploy your ML on. I think one of the visions that we had early on was, wouldn't it be great if you could just take your model, upload it to a service, and see how fast it would run on different hardware platforms, right? And this transition from the cloud, where most developers, do their development on server machines, to the edge and to the IoT, was something that was very painful. And there are tools that allow you to do this, but essentially you had to change tooling based on what hardware platform you were targeting. And so by making it as easy as possible to see, okay, this is the time it takes to run this model on the cloud. This is the amount of time, for instance, in terms of milliseconds that it takes to run on this edge device and IoT device. And being able to see all that information from the start, to then think about, well, what is the cost of then moving the processing closer to the edge? Is that something I can do on this platform, on this system? Or do I need to consider alternatives, right? Maybe this device is underpowered. Maybe I need to consider one that has enough acceleration capabilities. And ultimately being able to build this knowledge for the end user, I think is essentially what we're going after by solving the deployment challenge on multiple hardware backends, from the cloud all the way down to IoT, and backing the development of those innovations in this open source project.
Thanks, that's great. I think we're getting to the top of the hour. And so let me, first of all, thank you, Terry. This has been great. And then let me turn it back over to Evgeny.
Yeah, thank you, Terry. Thank you, Chris. It's been an amazing discussion, and I think OctoML has accomplished quite a bit, and I'm sure that we are going to see more milestones and more achievements coming out of your team, Terry, in the near future. So before we conclude, let me also ask my favorite question. I think we are at the tinyML Success Story series. What does it mean for you, success? What does it mean to be successful? It's kind of a personal / philosophical question.
Yeah, and I think it's such a great question. I think the answer is to do something that is fulfilling to you and to the people around you, that you're making a difference, and that difference moves society in the right direction. And ultimately, I think it's not a matter of prestige or money, but just this satisfaction that your job has accomplished a greater goal and has helped move our society in the right direction. and it's hard to feel the effects or the impact of that in the short term. But I think as the years go by, as the decades go by, being able to look back and think, this was truly something that has the potential and did exercise that potential to change people's lives. And so I think that's what I consider to be success.
Well, thank you, Terry. Definitely, OctoML is leaving a mark in this industry, I'm sure, and definitely your contribution is also there. Thank you again for this great conversation today, and wishing you all the best as the company grows.
Well, thank you very much, and it's been a real pleasure and an honor. And thank you for all the excellent questions, Chris and Evgeny. So,
of course,
it's my pleasure.
So just to wrap it up, let me acknowledge the sponsors again. So this is the list, and one by one, exclusive sponsors ARM, that's what Terry mentioned today, HMPulse, Qualcomm, Sentient, the platinum sponsors, ARM, DeepLight, ClickerTech, Reality AI, Renaissance, and we have several gold sponsors, PhotoHub, Maxim Integrated, which is part of Analog Devices now, Latent AI, NXP, Seed Studio, SenseML, ST Microelectronics, SynSense, and we have a list of silver sponsors. Again, thank you for joining today, and we will see you on June 7th at our next, at the June edition. Thank you.